पाठ ना
हेडिंग ଟା सर कोन दो
हां तो ताको थोड़ी से मुई करी हां हां
कोन
गुड इवनिंग
हम कोन ना
के करती गुड इवनिंग my dear first semester diploma students in our state. Today I will discuss two important theorems. First one is Polygon law of force and second one is Parallelogram law of forces. First, state and prove Polygon law of forces. Definition: if a number of concurrent forces acting at a point be represented in magnitude and direction by the sides of a polygon taken in order, then the resultant is represented in magnitude and direction by the closing side of the polygon taken in opposite order. This is the definition of polygon law of force. First, let us consider four forces, that is P1, P2, P3 and P4 acting on a particle O. It has been shown in the diagram figure, that is figure 1. In figure 2, P1, P2, P3 and P4 are represented by the sides AB, BC, CD and DE of a polygon ABCDE. Here AB is equal to P1, BC is equal to P2, CD is equal to P3, DE is equal to P4. AE represents the resultant of P1, P2, P3 and P4. Here AE is the resultant of P1, P2, P3 and P4 in magnitude and direction. The triangle law of force can be applied to polygon law of forces. Here AC is equal to FB plus BC. Here AC is equal to AB plus BC. AB is equal to P1 and BC is equal to P2. Then AD is equal to SC plus CD. Here AD is equal to SC plus CD. AC is equal to AB plus BC plus CD. You know that AB is equal to P1, BC is equal to P2 and CD is equal to P3. Then AE is the closing side of the polygon and it is represented by R. Therefore AE is equal to AD plus DE. AD plus DE. AD is equal to, we have already derived, AD is equal to AB plus BC plus CD. Therefore AB plus BC plus CD and DE. AB is equal to P1 plus P2 plus P3 plus P4. Therefore R is equal to P1, P2, P3 and P4. This is the derivation of polygon law of forces. Now I will discuss state and prove parallelogram law of forces. State and prove parallelogram law of forces. You know that this theorem states that if two forces acting at a point be represented in magnitude and direction by the two adjacent sides of a parallelogram drawn from a point, then their resultant is represented in magnitude and direction by the diagonal of the parallelogram passing through that point. Here, the two forces, here P and Q are two forces. These two forces, P and Q, are the adjacent sides of a parallelogram OACB. Here, forces P and Q acting at a point O be represented in magnitude and direction by OA. Here, OA is equal to P, OB is equal to Q as the adjacent sides of a parallelogram. Then OACB is completed. P and Q are two forces. R is the resultant of P and Q. This is the R. R is the resultant of P and Q. From C, draw perpendicular, drawn OA produce. That is, from C, draw CD perpendicular. Here, OA is equal to BC. Here, OA parallel to BC, that is P. Then, OP parallel to SC is equal to Q. Therefore, OA parallel to BC is equal to P, OP parallel to SC is equal to Q. In the right angle triangle OCD, here OCD is a right angle triangle. Therefore, OC square, this is the OC square, is equal to OD square plus CD square. OD square plus CD square. You know that OD is equal to OA plus AD. Here OA plus AD square plus CD square. Then OC is equal to R square, or that is the resultant of P and Q. Therefore, I am writing as R square is equal to OA plus AD square plus CD square, equation 1. Now, putting the values of AD and CD, putting the values of AD and CD in equation 1, we have. Now, you see, from the right angle triangle ACD, sin theta is equal to height by hypotenuse CD by SC, or CD is equal to SC sin theta. Here SC is equal to Q cos sin theta. Then cos theta is equal to AD by SC. Cos theta is equal to AD by SC, or AD is equal to SC cos theta. You know that SC is equal to Q, that is Q cos theta. Therefore, I am writing as R square is equal to OA, OA is equal to P, OA is equal to P. AD is equal to Q cos theta, AD is equal to Q cos theta square, plus CD is equal to Q sin theta. Therefore, R is equal to P square plus Q square cos square theta plus PQ cos theta, because A plus B whole square